So this is called motion. So that is very, very important. So you must give precise directions to someone so that you can know where to go. So let's look at vertical components. Just a quick revision for you that didn't watch the other two videos. In grade 10, what did we do? We said a man walked 3 meters east, and then 2 meters north, determine the resultant vector. So what did you do? The beginning from the first one to the end of the second one, and you got the resultant. So there's my resultant. But now, what do you want to do in grade 11? Now we're going to do the opposite. We're going to give you the resultant and ask you to get the original 2 vectors. So what we want to do is we're going to calculate the components. Another word for components, it's parts of the vector. So we want to know what is the original vector. So in grade 10, you've given the original vectors and you must calculate the resultant, or by either calculation or a scale drawing. In grade 11, we give the resultant and we want to know what was the original vectors back. So now we can say, calculate the components of the vector given. This is now in general. And now we can say the components. For components, we can now say the vertical and the horizontal component. So that's words that we can use, vertical or horizontal. If we don't want to use vertical, we can talk about up or down. That is not scientifically very nice to just talk about up or down. Or we can say in the direction 0 degrees or 180 degrees. Just for a quick revision there, north, east, south, west, north, 0, and then we go clockwise, 0, 90, 180 to 70 degrees. So that's how we use it. So we can say, so vertical can be either 0 or 180 because they're in that same vertical line there. So we can say the components, the vertical component or the up and down component or the direction 0 degrees or 180 degrees, or we can say Fy. If it's a force, Fy, because then it means it's vertical. Now horizontal, we can say right and left. Or we can say east and west. Now even for the top one we can have north and south. Or we can say in the direction 90 degrees or 270 degrees of Fx. So it depends on what you want to say. So there's different words, and that is what usually confuses you. You don't know all the words. So please make sure there's not just one word. So the physical science teacher will also help you to improve your English for synonyms of the same thing. So there's a lot of ways of telling you to do the same thing, and you must know all of them, because in vertical components you're going to really use a lot, especially when you do Newton's laws. So after vectors in grade 11, you will get to Newton's laws, and then you're going to use the vectors very much. You're going to use it in calculating friction, you're going to use it in calculating Newton's second law. So there's really a lot of places where you're going to use these vectors. Even when you get to electrostatics later in the year, you will also have vectors there. So it's very, very important that you must make sure that you have now the concept. Okay, mostly in grade 11 they can either ask you again a vector diagram, or then the scale drawing. That they don't do so much. We rather going to calculate the components than drawing them by scale. But let's start with an easy one. Okay, so now I have this vector. Let's say they've given me this resultant vector is 50 meters in the direction of 60 degrees. So now I take my protractor, and please remember 0 must be on the top, not 90 degrees. So in the direction of 60 degrees means I must go from 0 to 60. So there's the 60. If you don't like that, you can also do it like this and say, okay, but that is actually 90. So now I must count from the top 10, 20, 30, 40, 50, 60. So there I can make my mark for the 60. But it will be easier if you just put the 0 on top and you mark the 60. So now, according to your scale, I just want to turn my page. According to your scale, you're going to, let's make it was 50 millimeters long, according to your scale. So 50 millimeters was 50 meters also. So there I've indicated magnitude and direction. And please remember that little dot was just made there for where the 60 degrees, it doesn't mean the arrow must end on that little dot. It just 50 millimeters, so that was just my direction indication. I can either erase it also. The vector diagrams are drawn in pencil. So there's 50 meters, I'm writing the magnitude, and there's my direction, the 60 degrees. I can also write it there. Vector, magnitude, and direction. Now they say I must use a scale drawing to determine. Now I'm going to use two different colored pens, a blue one and a pink one. So what must I do now? I must calculate the vertical component. So how do I get the vertical component? I start from the end point there, and I go down to my x-axis. So that blue one will be my vertical component. So I'm not going to name it Fy. I'm busy now with meter, and meter is displacement, which is x, so I can make it xy. But if you're going to get confused between xy, you can just name it y if you want to. Now, how do I get the horizontal component? I start from the origin and I go to the right until I get to the vertical component. I put in my arrow, and that is, so now it's going to be xx or then just x. So what happened? Initially, I got xx and I got xy. I draw them in, and then I had to complete the resultant. So now I did it in reverse. I got the resultant, and then I had to draw in the original vectors. So now it's a scale drawing, so what must I do? I must go and measure. So I had a scale, my scale, which I had was 10 millimeters is 10 meters. So that means 50 millimeters was 50 meters. So now I measure, and I see this one is, it looks like 44. So this one will be 44 meters, and it will just be east. So I don't have to calculate anything. Or I can write 90 degrees, or I can write to the right. That doesn't matter, as long as I have a magnitude and a direction. Now the blue one, it looks like 25 meters. So it's 25 meters, and it will be north. Just make sure if you use east, then it must be north. You can't use east and up, or east and 0 degrees. The directions must just fit each other. So if you started with degrees, you can continue with degrees and say, okay, but east is 90 degrees and north is 0 degrees. So you can stay with degrees, or you can stay with the angles. Just make sure you have the same measurement for these two. So that was now my scale drawing. but we will rather do a calculation. If we're in grade 11, mostly, not always. Always is a very dangerous word for me. So we're not always going to do a scale drawing, but like in practicals, we're going to do both so that we can see if we get to the same answer. It depends on the type of thing that you want to test, but in this case, calculate now. So what I have now I'm going to do mathematics, and I'm strongly going now to concentrate on trigonometry. The following important thing for me is that you must always use the angle inside the triangle. So that is 60. I don't want the 60, I want the 30, which is inside the triangle. Now, how did I get 30? The two angles together gives you 90 degrees. So 90 subtracting 60 gives you 30. So I'm going to use the 30. Trigonometry. Opposite divided by hypotenuse, that is sine. So I'm going to say sine theta. And I'm first going to write myself a formula. So that will be my opposite side divided by my hypotenuse side. Or if they are named, then you use the names that's given. So I'm going to write sine 30, and that will be, in this case, be xy divided by 50. So now to get to the answer, I multiply by 50 on both sides. Please, if you do it, just do it in pencil, not in pen. But you don't have to show it. So you can say it is 50 sine 30, and that gives me xy. So xy equals then 25 meters. The unit that you're going to put in is the same as the unit given for the original vector. So if you calculate 50 sine 30, then you get 25. So I've measured quite accurately there to get the 25. So that's fine. Now to get the other side, I'm not going to do Pythagoras. The reason why not is when you get to the calculations using Newton's laws, you're not going to calculate Pythagoras. You're rather going to use the trigonometry. So I want you to practice the trigonometry when doing these calculations and not go back to Pythagoras. Sometimes there is a Pythagoras that we must use, especially when we get to electrostatics, then we use Pythagoras. But when we get to Newton, we're not going to use Pythagoras when they say calculating the horizontal component. They usually ask it in different calculations, so that's why I don't want to do it. Okay, hypotenuse, the adjacent side over the hypotenuse side, so that will be cos theta. So cos theta will be adjacent divided by hypotenuse. Anything, you can also use tan if you want to, that doesn't matter, as long as you use the correct sides. So cos 30 will now be x, what I called it, divided by 50. So I multiply by 50 on both sides. So I get 50 cos 30, and that gives me now xx. So xx equals, so if I work it out, 50 cos 30, my answer will be, and please don't write 25 square root of 3. The instruction on the paper tells you that you must round to 2 decimal places, and that is 43,0, and it's now 0127, so it's 43,3 or then 0, and it will be in meters. So if they just ask you to calculate the magnitude of, that means you just calculate the value with a unit and the value with a unit. So this is very important calculations that you're going to combine further on with friction calculations, with Newton's second law. So there's a lot of places that we're going to use this. So rather practice the trigonometry. Don't be afraid of the trigonometry. And also, physical science is applied mathematics. So make sure you can apply the mathematics in different situations. So there's your original vector. So I've measured 44, that is near enough to the 43,3. If I've measured 54 meters, for instance, let's say I've drawn that vector like that, it wasn't straight up, I draw it like that, then the bottom one will also be wrong. So then I can see if I've measured 54 there, or maybe I just made a writing error and I write 54, and if I calculate it, it's 43. That is too far apart. But 43,3 and 44, that is fine. And you can't measure precisely 43,3 on your ruler. So just make sure if we ask the calculation, you must do the little sum there, you must do the calculation. If they ask a vector drawing, a scale drawing, then you must use this. Okay, now what can we do further on? Because I'm sure you know that this won't be all for grade 11. It can't be that easy. So what we're going to do now, we're going to combine some vectors. So if I have my Cartesian plane or my xy axis that I have there, they can ask me 3 vectors. So I can have a vector, let's make this one F1, and that is 3 Newton. And there's a vector F2, and that is 20 Newton, direction 60 degrees. And I have another vector there, F3, and that vector, oops, that must be 30, sorry, let me just make it correct there. It's 30 Newton and 20 Newton, and this one is 40 Newton that they've indicated. Now they give you this picture, and they ask you calculate the resultant vector of the 3 vectors. Okay, calculate the resultant vector of that 3 vectors. So that's the question that they're asking you there. Now you don't know what is going on. What you must do now, you must break it down. So for everyone, you must look at the vertical component and a horizontal component. You can decide, you're going to calculate all the vertical components. So what you want to do is, you first want to make all the vectors one vector. So there must just be one vector vertical, and there must just be one vector horizontal. So we're going to combine it. So what we're going to do, we're going to say vertical. So now we're going to look at the vertical component of all the vectors. So I'm just going to look now at the vertical ones. So what is vertical now? If I take F1, it is vertical. So I'm going to convert it now. F1 equal, I just want to get another pen. F1 will now be 30 Newton. Now I want to stay with up as positive and to the right as positive. That is my convention, my choosing of directions that I want to do. So F1, what will F1? It will be 30 Newton down. Now how do I write 30 Newton down? I write minus 30 Newton because it is 30 Newton down. Now I take F2. F2 isn't that easy. What must I do with F2? There's my F2. So that will be Fy because it is vertical, and that will be Fx because it is horizontal. So now I'm breaking down that 20 Newton into its vertical and horizontal components, because I can't work with an angle and then with things that is directly on the axis. That means they vertical or the horizontal. Now you have this one with an angle, so I can't do that. I must break everything down that they must be either all vertical or all horizontal. Okay, so there's now, if one wasn't a problem because it's already vertical, I must break down F2. Again, what is important there? I must use the angle inside the triangle. So I can't use the 60, I must now make it the 30 because it must be the angle inside the triangle. So now what do? It is opposite divided by hypotenuse. So I'm going to write now there, F2 will be sine 30 will be Fy divided by F2. So Fy will be F2 sine 30, and that will be 20 sine 30. I will just leave it like that because I'm going to substitute it in the rest of the question. So I'm not going to work it out now, I'm just going to leave it like that. So it will be 20 sine 30. If I look at F3, now what is F3? I just want to get my picture again. F3 is just horizontal. If something is just horizontal, it has no vertical component. So that will give me exactly 0 Newton. So now I'm going to add them together. So I'm going to say F resultant vertical. So it's F resultant vertical. So your letters become smaller there. F resultant vertical. It's subscripts. Please remember they're not going to stand on the line. They're hanging from the line there. They're subscripts. So now I'm going to say it's F1 vertical plus F2 vertical plus F3 vertical. What is F1 vertical? F1 vertical is down, so it is negative 30. Plus F2 vertical is upwards. You can even make here a vertical if you want to. F2 vertical is upwards, so it will be positive 20 sine 30 plus, and F3 has no vertical component, but please, you must write the 0. You can't omit the zeros. That means you can't leave out the zeros. The zeros must be there, so it's very, very important. Just a little joke for you. I always tell my children, if zeros is not important for you, when you leave school, maybe the boss is going to offer you 10,000 Rand a month. You can get out 10,000 Rand a month. You say, oh no sir, the zeros is not important to me. Okay, then he cuts off a 0. Oh, the other 0 is not important to me. Then he just pays you 100 Rand instead of 10,000 because you said the zeros is not important. Okay, so please remember the zeros are important. So the lesson for today, zeros are important. In physical science, the 0 is not just there, you can leave it out, that's fine. It tells me something about that component there. So although it's 0, I must indicate the 0 there. So now I'm going to put it in negative 30 plus, and it is 20 sine 30, and you get an answer then of negative 20. So you can see on my calculator, I read it in exactly minus 30 plus bracket 20 sine 30, and that gives me negative 20. So if it gives me negative 20 Newton, it means it is 20 Newton down, or in the direction 180 degrees. So now I've calculated all the vertical components together. So that means I've combined all 3 vectors just to get me one vertical. So now I'm going to do the same, combine all the horizontals just to get one horizontal. Okay. I just want to fold the page so that we can see our picture. Okay, so the picture won't fit in. Let's see, there's our picture there. So I'm going to look now, just want to put it there at the top. Okay, so there's my picture. I'm going to look now at all the horizontals. So I'm going to write horizontal. You will see I like to make headings, then your teacher or the examiner at the end of the year exactly know what you are doing. So don't just write there 30 plus 20 sine 30 equals 6. We want exactly. You must train yourself, formula, substitution, answer. Okay, now I'm going to go to F1. F1 horizontal. Now what is F1? F1 is vertical down. If something is vertical down, then it doesn't have a horizontal component. So this horizontal component of the vertical is 0 Newton. So there isn't one because it is vertical, there's no horizontal. If I look at F2 horizontal, now where's F2? That is that little pink one, Fx. So if I look now, it is adjacent divided by hypotenuse. So I'm going to say cos 30 equals adjacent, which is Fx, divided by hypotenuse, which is 20. So multiply by 20 on both sides. Fx is then 20 cos 30 degrees. Just leave it as it is. I'm going to use it in my calculation a little bit later. Now if I look at F3 horizontal, that is to the left now. F3 horizontal is to the left. To the left is negative because I choose up and right as positive. So to the left is negative, so that gives me negative 40 Newton. Add them together. F resultant horizontal gives me F1 horizontal plus F2 horizontal plus F3 horizontal. So F1 horizontal will be 0 because it's vertical, it doesn't have a horizontal component. Okay, now just be cautious, the 20 cos 30, picture net, it is to the right, because it's to the right it's positive. So I can say plus 20 cos 30, it's to the right, plus, and this one will be negative 40 because it is to the left. So I'm going to put in 20 cos 30 minus 40. Okay, and that gives me negative 22,68 newtons. Because it is negative 22,68 newtons to the left. It's a vector. Vectors have two answers. Now I must combine this. Now I draw myself a new picture. Because what is the question? Initially the question was calculate the resultant vector of the three vectors. So I just want one answer for the three of them together. So now I've calculated the vertical. I've calculated the horizontal. Now I draw myself a new diagram. I must draw 20 Newton down. It's not a scale drawing now. I just draw 20 Newton down and I draw 22,68 Newton to the left. Important, complete a parallelogram because it is simultaneous vectors. How do I know from that picture, first picture, it is simultaneously? They all three start at the same point. So because they all three from the same point pulling in three different directions, it means it is simultaneous vectors, and simultaneous vectors you use the parallelogram method. So I complete my parallelogram, and from that origin there will be my resultant or my F net that I'm going to calculate. So I draw myself a new picture. They're at right angles from each other, so I can't just add them together. I must use our friend Pythagoras. So f net squared equals, now you can stay with f resultant vertical squared plus f resultant horizontal squared. Okay, the vertical is down, so it will be negative 20 squared. That one is to the left, so it's negative 22,68 squared. And please remember, boys and girls, you can't change your convention. That means the direction that you've chosen from the beginning, if you've chosen up as positive and to the right as positive, you must stay throughout the whole calculation with that. You can't now decide, okay, but now the 20 must be positive and the 22 also, because that's not the direction you've chosen from the start. You must stay with that convention. Okay, you don't have to write out what is each one of them. You can just put it in your calculator, 20 squared plus 22.68 squared, and get the square root of the answer, and just write as the answer 30,24 Newton. That is my resultant vector in magnitude, but I still need a direction. Now you can decide which direction you want to do. I want to calculate that one, because why? There's my axis, there's my resultant. I must also always measure from north clockwise. So that's what I'm busy doing now. So I want to calculate that angle. So I'm just going to say now tan theta, because I completed the parallelogram, opposite sides are equal. So that one will also be 22,68. So it will be my opposite side divided by my adjacent side. So that means that tan theta will be 22,68 divided by 20. So now I put it in my calculator. Shift tan 22.68 divided by 20, and that gives me 48,59 degrees. But that is not the direction, because now I've just calculated that little part theta. I still want that whole angle. So if I start at the top there, it will be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So now I've already covered from 0 to 90, from 90 to 180. So I've already covered that whole part up to there, plus another 48. So my direction, just want to go on this side. So my direction will be 180 plus theta. So it will be 180 plus 48,59 degrees. So that gives me 228,59 degrees. So therefore, if I have that final resultant, F net, it gives me 30,24 Newton in the direction 228,59 degrees. And that's my final answer. Now I like my kids, but that's personal. Just to draw the answer in a little block. Now just to finalize this session, I'm going to write it for you step by step what you must do, and then it is easy to do the calculations then further on. Don't be scared when you get the total resultant 0, because that we will do in the next lesson. But let's see, what have we done? I'm going to use a little block there. We started by calculating. Let's go back to all the calculations. We've calculated all the verticals together, and we calculated a resultant vertical. So I change everything into their vertical part. So my steps, so let's write calculation steps. I like to give you a recipe to calculate, because then it will always stay the same. The calculations won't be always the same thing that you calculate, but now the way that you do it will stay the same. So the calculations, you're first going to calculate the resultant of the vertical. So you're going to calculate the resultant of all the verticals together. Then you're going to get the resultant of the horizontals. Okay, you can decide you want to swap those two, that is fine, as long as you calculate the resultant of the horizontals then, and then the resultant of the verticals. Then the third one that you must do, you must draw a new vector diagram. So you must draw yourself now a new vector diagram. So that is what I've done there. I've drawn myself a new vector diagram. Then I must do addition. So now what must I do with the addition? I do Pythagoras. I do Pythagoras there. Then I must calculate an angle. Calculate an angle. So that I've done. I've calculated the angle there. I like using tan, but you can use sine, cos or tan. That I've calculated my angle. And then I calculated the direction. So I calculate an angle. Then I do the direction. If it's already in the first quadrant and it's already measured from 0, then you don't have to do this direction part, but mostly you're not going to find it in the first quadrant. That means there between 0 and 90 degrees. You won't usually find it there. You will rather find it somewhere else. So that's why you must do the direction. And then step 7, you write the final answer. Oh, dan moet ek staan right. Okay, so there's your 7-step calculation. So you start by making all the verticals 1. So you calculate the resultant of the verticals. Then you make all the horizontals 1. You calculate the resultant of the horizontals. Then you draw a new vector diagram. Then you do vector addition by using Pythagoras. Then you calculate an angle. You do the direction and you write down the final answer. If they say just doing the magnitude, then you leave out step 5 and 6. If you must just do the magnitude, then it's not necessary, then you can stop. But the calculation steps, that is what you do and that is what you apply. And like I said, don't be afraid when the answer is 0. So we will treat that now in the next part when we do equilibrium of vectors.